everyone, July 23rd. What do we have today? Minimum score after removals on a tree. There is a undirected connected tree with n nodes labeled 0 to n-1 and n-1 edges. You are given a 0 indexed integer array, nums, of length n, where nums I represent the value of the ith node. You're also given 2D integer array edges of length n-1, where edges AB indicate that there is an edge between node A and node B. Remove two distinct edges of the tree to form three connected components. For a pair of removed edges, the following steps are defined. Get the exclusive OR of all the values of the nodes for each of the three components respectively. The difference between the largest exclusive OR value and the smallest exclusive OR value is the score of the pair. For example, say the three components have the node value this, this, and this. The three exclusive ORs are this 6, 8, and 3. The largest is 8, smaller than 3, and the score it is 5. Return the minimum score of any possible pair of edge removal of the given tree. N is 1,000. N is 1,000, which means the edge length is, the edge length is 1,000. But you need to pick any two, so we can actually go through all possible combinations because it's 1,000. So now the question is, once you pick two, you need to figure out what is the exclusive OR of every single one, right? So it turns into a question of finding the exclusive OR. I mean, there is a concept of prefix exclusive OR. So you can keep exclusive OR. Actually, I'm not sure. Exclusive OR of something. Hold on, let me think. So like, we say I have A exclusive of B exclusive of C. I have this. And I have A and A exclusive of B. Right? So I have like A, B, C. So I want to find B exclusive of C. To define B exclusive of C, all I need is A exclusive or B exclusive of C exclusive of A. So yeah, a prefix will work. So like if I want to get these two, I get this minus this. It's just exclusive of this. Of course, these two become 0. Okay, so that's the property. And then we have the tree, right? We have the tree. So how do you find the subtrees exclusive OR? Right, so we have 5, 4, 11, say we know the exclusive of all subtrees, right? If I know the exclusive for of a subtree, any subtree, then we store it at the root. Then when we sever, then we have the exclusive all of the subtree, because it says it has to be two distinct edges. So we also need to make sure after we do two edges there will be three components. Will that always be true? You delete two. Well, when you delete one, no matter how it is, when you delete one, you definitely create two. When you delete another one, you create, yeah, so any two will work, right? So if I say this is 5, actually this is not 5. If we want to do exclusive all, then this is 11, this is a 1, this is a 4, and this should be 11 exclusive 4. What's 11 exclusive 4? Use this. 11 exclusive 4. 15. Okay? So this will be 15. So the top will be 15, 1, and 5. 15, 1, and 5. That's 11. Okay, so that's that. So if I split it out, right, so when you split out, you cut an edge. And we also need to pick who is a root. I think it doesn't matter who is a root. We can pick whoever is a root. Oh, it doesn't matter. We'll pick whoever is a root, right? And then we just delete edges. And once you delete edges, the edge that has been deleted, like if I say I'll delete this, I'll delete this, right? So the edge gets deleted. I do the traversal, okay? I do the traversal starting from certain, and then we can actually decide who the parent is, right? Who the parent is. So when I delete it, I know the subtree, right? This will be the subtree. So this will be 15. I delete this, this will be the subtree root. This will be 1. So I have 15, 1. All we need is to find the remainder, right? The remainder. So I know this, right? Which is the exclusive of, actually no. I think I had to exclude of 5 as well. Because I have 15. So this exclusive of this, exclusive of this, this. So it's 15, 5, 5. I have to do 5 as well. Yeah, this is 14. So I just exclusive of this and this, then I'll get a remainder, right? So yeah, let's simulate. So what do we have? What we have, let's say we sever this and sever this. So I have 1, 5, and this will be 14 exclusive of 1 exclusive of 5. So this will give us 14 exclusive or 1 exclusive of 5. So this will give us 10. Okay, so what we have is 10, 1, 5. So the answer is 9. So basically we can use this scheme to find every single pair. Okay. So all we need to do is traverse it. We'll find who the parent is, right? Everyone will have a parent, and so yeah. So in this case, like I say, so we have a parent array, right? I have a parent array. So I have 0, 1, 2, 0, 1, 2, 3, 4. Right? So 0, who's the parent? So 0 parent is 1. 1 doesn't have parent, so it'll be negative 1. 2 parent is 1. 3 parent is 1. And 4 parent is 3. So I do something like this. We can actually just say, let's make 0 is the parent, right? 0 is the lord. So 1 will point to 0. 2 will point into, actually I don't know what 2 point into. So now we have to just traverse it. Because traverse it, you also have to get the exclusive OR. So you will do traverse, you do exclusive OR, and then you do the parent. So now I have this, right? So I say if I want to break 0, 1, and then 1, 2, right? 0, 1, and 1, 2, I go to 0. 0 has parent 1, and a 1 has parent negative 1, right? So like if I break 3, 4, so I can go to 0, 1, 2, 3, 3, and then 4. So I check these two. So I know 3 is the parent. So if I break 3 and 4, then what I get is 4. It should be the root. Yeah. So my idea is like this. Here is the idea. We will traverse the tree. I pick a root. I pick a node to be the root, and then traverse the tree. We will compute the exclusive OR of all the nodes in a subtree and save it in the node in the subtree, in the root of the subtree. We will also keep track of each node's parent. Then we brute force all possible pairs in edges, all pairs in edges, and use the parent relationship to identify the exclusive OR of two subtrees, right? Two children subtrees. For the last subtree, we will use the exclusive OR, right? Or use the exclusive OR. But hold on, let me think one more time. So when we break, we get this, right? But what if I break here? So I break here and I break here. Oh yeah, I just exclusive of these two. Then it will become this. Because this is the exclusive of every single one. And then when you break it, you just exclusive of these, and then that will work. Yeah. We'll use the... But who... Oh, the root. We'll use... for the last tree, its exclusive OR, right? Its exclusive OR is its roots total exclusive OR to exclusive OR the two subtrees. Exclusive. It doesn't even make any sense. That's fine. This is good enough. Okay, so what do? We need to first, we need to traverse, but in order to traverse, we need to build a, we have to build a graph. Okay, so we'll build a graph, and then we'll traverse, and then we'll do that, and then we'll do that. Okay, so we need to do unordered map, int, and we can do a vector. Actually, yes, a vector of int, call it graph, for auto const e of edges. I think it's const auto. Sorry, I think it's const auto. Yeah. Can I just say graph e 0 dot pushback e1, graph e1 dot pushback e0. Alright, so we get a graph, and then we need to have a void traverse graph. This is gonna be a constant. So we have a graph. What else? We need a node parent. So we have node, a parent, we have the graph, and then we need to say vector int exclusivos. This is just going to be a reference. Parents. Okay. And then first thing we'll say parents, node where you put a parent. And then, oh, this needs to return int. And then exclusive all, we'll start with 0, right? Yeah, exclusive all will start with itself. So exclusive all's node will equal to, oh, we need a value. Nums. Okay, here const std vector int nums. Right, we'll always put nums there, and then for const p of const auto children, child of graph dot at node. Oh, what does at return? I think it should be auto it shall equal to graph dot find node. Right? And then we say if it is not equal to graph dot end, then we do this. Alright, and at the end we'll return exclusive sure that it has not been visited before, we can use parents or use exclusive or. Actually, I think exclusive or is better because the value I think is all positive. Yeah. It's actually, yes, the value should be all positive. Now we say if child, right? If exclusive or child is larger than larger equal to 0, right? Not visited yet. Right, if it's larger equal to 0, then what we're gonna do, it will do traverse child and node, graph, nums, exclusivals, parents. So this I can say exclusivals node, exclusival equal to this. Alright, so I'll go through everybody and I'll return this. So that's traverse. But before traverse, I need to set up vector int. I need n size. Right. So this one will be exclusive ors, and everybody will be negative. Vector int parents. Parents actually fine. I don't really care who. Actually, I think everybody should be -1 as well. Okay, and then we'll do traverse. So I'll just say I start with node 0, its parent is -1. Now I do graph, nums, exclusive ors, and parents. Right? So this will give us the things to work with. So the parents will have all the parent, and exclusive ors will get all the exclusive or. And then what we're gonna do is we need a result. We need a minimum result. Minimum score. Minimum score is the max minus minimum. Okay. So what we need is, we have 3 values. So we need to give the max value, minimum value, and we need so int res equal to minimum int max, right? And so for int I equal to 0, I smaller than edges, it says it's n-1, so I think I can just use that. Yeah, n-1, I plus plus, for int j equal to I plus 1, j smaller than n-1, j plus plus, right? So we have pairs. So now we have the first pair. I need to know who is the parent and who is the child, right? How do I quickly do that? Well, we can write a function. All we want to know is so we can say get, actually traverse, I think I should capitalize this, let's capitalize it. So what we need to know is get subtree root, right? Get subtree root. Now what we have is 2 edges. Okay, const std vector int, no, just 1 edge, right? So we have an edge, we have const std vector int parents. Okay, so we can say A is edge 0, B is edge 1. Okay, so that's the 2. Then we need to know who is. Then we just check on the parents, right? So we say if A is equal to parents B. Right, if A is equal to parent B, so A is B's parents, then we'll return B. Otherwise, we'll return A. Because one of them has to be the parent. So that's that. So here, basically what we're gonna get is so subroot 1 is going to be get subtree root edges I and parents. Okay. And subroot 2 is get subtree edges j and parents, right? So now we get a 2 subtree root. We'll get their thing as well. And then all we need to do is you want to create a new one, or is that easier way to find a max among 3? Yeah, we'll have a bigger one, we'll have a small one. And then we compare. So if bigger is bigger than that. Okay. If this is bigger than that and this is smaller than that, and I'll have to, yeah, I don't think it's, I think it'll be easier to get the 3 exclusive ORs, right? 3 values. So I can just say vector 3 values, right? So 3 values will be exclusive ORs subroot 1, exclusive ORs subroot 2, and exclusive ORs 0, exclusive OR subroot 1, oh shoot, subroot 1, and exclusive OR subroot 2. Right, so that's the 3 values. And then we can get max score, not max score, max val shall be max element 3 values, right? But this is going to need to, I think, do this. No match for, wait, hold on, do I have to do this? Huh? How do I call max element? Oh, wait, hold on. I think it has to be dot begin 3. I might as well just sorted it, right? Might as well just sort values dot begin 3 values dot end, right? You sort it, and then we have this. Then we can say res shall equal to minimum 3 values dot back minus 3 values dot top front, yes, front. Res. Okay, and then we'll return res at the end. All right, let's give this a shot. All right, let's give this a shot, and we'll see how this one goes. coming back, I'll do some debugging. It does not work. It does not work big time. Okay, so we have some serious issues that we need to deal with. Okay, let me redo this. Right, so we have 0. Actually, I don't even know what the tree will look like. So if I do 0, 1, so 1 has 2, 3, 2, 3, and then 3 has 4. I think this will be the tree that I'm getting at. And 0, the value is 1. This is 5. This is 5. This is 4, and this is 11. Right? So if we do exclusive OR, then so we have 11 exclusive OR 4. That's 15. Alright, so this will be 15. Actually, let's just do this. This will be 15. And this is a 5. So this one will be 5, 15, and then 5, 15, and 5, which is 15. And then the top one will be 15 exclusive OR 1. Actually, I don't know what that is. I'll be 14. Right, so this will be 14. So let's just try 0, 1. If I cut 0, 1, then what we get? Oh, you cut 0, 1. And what else do you cut? You cut 1, 2. So you cut this and you cut this. So you cut this. So now we have a 5. And you cut this. Ah, I just get 15. Because it's 15. Now it becomes 15. And 0. Because they're on the same chain. That's why it's not right. Right? This is good. Now we cut here. And this is no good. Because it shouldn't be 15. Right, it shouldn't be 15. And this will be 1. This is good. Right? Actually, this is also not good because you're doing both. You're doing it twice. So it should be this is 2. Right? You get rid of this. First cut. Actually, we should do like with first cut. Right? First cut. I have the subtree actually give me this, right? So we have 15, yes, and the other one. What is the other one? Well, it's the parent. So the parent should be. So I need to know. The parent will be actually 1, right? Parent will be 1. This will be 15. And then I cut the second one. When I cut the second one, it depends on which subtree the second one belongs, right? So now the second one belongs in this subtree. So when I cut it, right? When I cut it, I know who the root is, right? But it doesn't matter. When I cut it, then the subtree. So this is good, and this is also 5. 5 is good. but we need to handle this 15. So it should be 15 exclusive of 2, right? Should be 15 exclusive of 2, which will give you 13. And then the answer of this setup is going to be 12. 13 minus 1 is going to be 12. That is not right. It should be 15. Right, this is a 15 because I have 2 exclusive of 3, and now I have 4. I have 11, and then we have 5. Wait, hold on, hold a second. It's 1 is 5. Right, I do 5 exclusive of 15 exclusive of 5. That's why I say this is 15. So start with 1. So 1, 2, 3, 4. 1, 2, 3, 4. Yeah, so 5, 5, 4, and 11. 5, 5, 4, and 11. 4 and 11, yeah, it's 15. Right? And then 0 at the top, because 0 is 1, and then 1 exclusive of this becomes 14. And then when you cut it, this is become 1. You cut it, this is become 5. So 1, 5 is correct. Right? 1, 5 is correct. So what you need is the remainder, 1, 3, 4. 1, 3, 4 is 4, 11, 4, 5, 11, right? 4, 5, and 11. It should give you 10, right? It should give you 10. Which means in this case, when I sever it, it should be 15 exclusive of 5. Yes. So, because now this is the root. So when you sever this, you take this part, and this shall lose. You shall lose 5. Right? I don't think this is the part that I paid attention to earlier. The root, your parent, need to lose your share, right? The parent need to lose your share. So now this should be 10. Then it's right. So what needs to change is after you remove the first, you get a parent. You get not really a parent. You get 2 parts, right? You get 2 parts. You get a I need both, right? I think I need both. I need a parent and I need a child. I need both. So I know both, right? So what I need is a parent and a child, right? So I need a parent node and I need a child node. And based on this, I can compute the updated exclusive all. So we can say exclusive all parent and exclusive all child. Right, that's what we want. But basically it has these 2, we have these 2. And then when we make the second cut, right? When we make the second cut, I need to know where that second cut happens, from which subtree the second cut happens. How do I know that? How do I know from which subtree the second cut happens? So what we need to know is here, like this is the first cut. When the second cut, I need to know that it's not from the 0, but from this 1. How do I know this? How do I know this? Yeah, one cut you get like 2 separate, right? You get 2 separate. So how do I know from which click the second cut comes from? Interesting question. Interesting. I think I should be able to tell, right? It's essentially given an edge. You need to tell me from which subtree you come from. How do I know that? How do I know that? If we can solve that, we solve the whole problem. It should be everything that a node. So I can go back to the, so like you have 2 nodes, they're connected, and then they might have like other things that's connected, right? And then when you sever this, and how do I know which component, which one of them the other one belongs? Especially following a hierarchy, right? We're following we traverse follows a hierarchy. So when you sever it, right, we'll have like a tree structure, top down, okay, top down. And then when you sever something, right, when you sever something, I can, because there's only 1,000, but you're not going to traverse every single time. Like, I need to know who the, so I can put a set here. All the children will be here. All the children will be here. And all the children will be here as well. So when you sever it, right? So we have this side, and then we have this side. And then the second edge, right? The second edge. So we check. So I know this. I know which one this is. So what I need to do is the second edge, I'll compare to this set. Because both needs to be in, so both will definitely be in one of them. Then it will be in both. Right? It will be in both. That's not gonna work. Right? It will be in both. No. No, 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 no. So if you sever this, if the edge is here, right, they will not be in this part. Okay, so the edge is either in this side or in this side. If the edge is in this side, then the edge will be in one of them, but not in the other one. Right? It will be in one of them, but not in the other one. If the edge is in here, then it will belong to both. So that's how we tell where the second edge is. And by knowing where the second edge is, right, and then we can do the same thing. Then we'll sever it, and then we will get the component, and then we'll get what this one is. And okay, so yeah, I think it's solvable, but it's a bit late, so I'm not gonna do it right now. What I'm gonna do is I'll copy paste this, but I think this one is solvable. It's definitely solvable. So this will be a copy and paste, but I just need more time. Okay, so this is a copy and paste, but I think I can solve it. I just need more time. So we will run this, submit this, and then we'll go back to it. Yeah, I'll go back to it. Yeah, I'll go back to it. This is not very wrong. Yeah, we just need this last piece. This last piece. We don't need the parent, basically, array. Oh, yeah, we don't need the parent array. We just need a set, right? We need a set. All right, that'll be it.